All right, we were talking about objects. Any questions on what we saw last time yet? All right, so we started by making, well, we want to make an enthusiastic student object. Or at least, really I should be using better words here. We want to define what an enthusiastic student is. So we write this definition, we call this definition a class. Then, whenever we want to make an instance of that object, Python will just go look at the definition and use all that information to go create it. So right now we're writing the definition of what it means to be an enthusiastic student. And as we saw last time, we start with this, class, whatever we want our class to be, colon, and then everything inside that class gets indented. That's how we start writing our own classes. Oh, and you can't see anything. Why did anyone say something? Did you just want to see how long I would go? There we go. All right. So that's what I'm talking about right there. We start, we say class, whatever we want. There we go. We started our class. Then there are three big important things we need for our classes. The constructor, and I said like asterisk. There's a lot of asterisks applied to all this, of course. But typically it's your constructor, the class attributes, and the methods. And technically the constructor is just a method, but it's a special one. And we tell Python, okay, we're going to start writing the constructor, and the function for the constructor is going to be called underscore underscore init underscore underscore. And it must, in the first location, have the parameter self. We could technically call self whatever we want, but just call it self. And weirdly, we saw last time, self is like a pointer to itself. This will become more obvious as time goes on. So we started to write the constructor. There's nothing in it. But with this, let's check something out here. Oh. My goodness. Look at that. With this constructor, there's nothing in it. That means there's no special code we want to run when the constructor's called. We're going to add special code, but as of now, there's nothing. But with just these two things, really just like the 2 lines of code, I mean, I know there's comments in there, but in the 2 lines of code in the class, I can already make an instance of this enthusiastic student object. A student is the variable name containing the pointer that gets us to this object. This right here, when we use the name of the class, that's going to automatically go and run the constructor. It's going to automatically run underscore underscore init underscore underscore. Also, you will notice, despite in the definition of the constructor, we've got this parameter self, I actually don't need to put anything there. Python adds it in there for you, so you don't actually have to write it when you call those functions. Just to prove to you that when I call this constructor, when I call this line of code right here, to prove to you that this is running, I'm going to write something that's perhaps a little rather silly, but I'm going to do it anyways. And now I'm going to hit run. Look at that. The code saying print I ran. We printed it out. We can see it right there. That happened on line 1 in that second cell. Well, I mean, really it happened inside the function, but by calling that constructor on line 1 in that second cell, it ran all the code in the constructor. All there is a print statement. It's a little useless, but the point is, by calling enthusiastic student, we ran the constructor. You will also notice that before, when I said print a student, it gives me all this funny stuff. It says, what's this underscore main? What's up with that? Then we see enthusiastic student object at OX7FB1E7CCF4A8. Any idea what that is?
Isn't that the RAM address?
That's the memory address where that is. See what happens if I rerun it. I wonder if it'll change. Look, every time I run it, it's going to create a new object in a different place in RAM. Look at that. I want to know what memory address that is. I'm going to copy this. Wow, that's a big number. Times 10 to the 14. Google's got a lot of RAM. So when I say print out this thing, I guess all it's doing is saying where it is in memory. That actually here, I'm going to talk about this more a little later today. I'll make you wait for that one. It's a lot of fun. And then of course below I'm saying print out the type of a student. It's saying, oh, it's a class in main, enthusiastic student. It's telling us the type. It has its own type. It's enthusiastic student. Great. Any questions about this? This means everyone understands this completely. They're happy. All right, well, let's see where this goes. So we wrote the constructor. Great. We can have our constructor take as many parameters as we want, but it has to start with self. Weird rant about self. So now we want to add a couple of things to our constructor. I'm going to replace the constructor with this version of it. There, I just updated it. There's a lot going on here. Let's break this down. First, you might notice, well, I added a bunch of parameters. We've got self, but we also have first name, last name, student number, and current average. Does anyone remember what it means when we add like equals, like assignments in a parameter list?
Like with no information given.
Exactly. If you call this function without passing it any of these values, it'll take on those values by default. Then you will see I'm saying self.firstName is equal to first name. Self.lastName, last name. Self.student number, Self.curaverage, curaverage. Here's an example of where self actually is perhaps useful. Those 1, 2, 3, 4 variables are going to be the class attributes. This is going to be information about that student. That's like me asking you, what's your first name?
Roman.
What's your first name?
Dominic.
What's your first name? That's that. However, there's actually 2 variables with the name first name in that code. One is the parameter. The information that was passed as a parameter. But the one self is not the parameter. It's the object variable called first name. That is different than the parameter variable called first name. So when I said self dot, I am very explicitly telling Python, this is a variable, an attribute that belongs to you. This is yours. It belongs to you. And if we ever, in Python, if we ever want to assign something to be an attribute in Python, we always say self dot whatever we want our variable name to be. So, the fact that we have first name twice, really, that's two versions of the variable. And Python's happy with this. It's not saying, oh, this is ambiguous. I have two variables with the same name. No. It's happy with it because self.firstName is entirely different than first name. If you don't like this, here's a simple solution to eliminate any worries of ambiguity and confusion for you. Do something like this. I'm just giving you an example. I don't know. And then replace them down here as well to like F name, L name, SN, and CA. Great. It's fine with this. So now, I mean, to you as the programmer, although Python, there was no ambiguity to Python, if you're a little more comfortable with something like that where you just make sure the variables have different names, go ahead, do it. I encourage you to do that if it just helps you separate what's what. But the point is, self dot variable name, that's its attribute. It's different than the parameter or any other local variable that might have the same name. So, I mean, seeing as John's first name, last name, SNCA, seeing as we're setting a whole bunch of values, and we actually have these default values, let's see what happens if I do this. So I reran this. It was happy to create it. It didn't print out I ran because I got rid of that code. I mean, I could add it back in if I want. Print I ran. R ran, I ran. So it comes back, great, but let's get rid of it. Just like any other object we've been using so far in this class, I can say, hey, what's your first name? Look, Colab even populated that list for us. Colab is smart enough to go, hey, I know what this class's attributes are, because you wrote it. Look, it's giving me the options. This is just like when you said, like, numpy array dot, and it filled it. It knew what the attributes and methods were. Colab still knows it. It said, this is the one you wrote. I don't know about you, but that's awesome. So I could ask, hey, what's your first name? Notice that a student is pointing to this instance of the object. Self, the self that belongs to a student, points to the same thing A points to. They're pointers to the same space in RAM. And that's where we get to that object. So when I say, hey, a student, what's your F name? Well, I guess it's actually first name. Oh, it's John. Why? Well, because by default it was John. But you know what? I'm going to give it a Bob. Smith. Their student number is 111, I don't know, however long. And they've got 51 in the class. They're getting by. Well, now it's Bob. Why? Well, because I said create one called Bob. Let's have B student be the default one. We've got Bob and John. Both A student and B student, those pointers to those two separate enthusiastic student objects. Both of those objects have self, but their self points to the specific instance that they are. I'm going to draw it. There's one. There's the other. It's kind of hard to see. This marker's not great. For A student, points to this. B student points to this. And these objects have first name, I'm lazy, I'm just put LN for last name, student number, and CA for current average. But they also have self, which is just a pointer to itself. And this one has the same thing. SN and CA. Except B's John, and so on. And here we've got Bob. Oh, and of course I forgot self, which is a pointer to itself. Both of these objects have a first name, but they're different. I mean, they could be the same, but they will be different versions of something that happens to have the same values. They both could be Bob, but they will both have first name attributes with the value Bob. This is like me saying, what's your first name? What's your first name? What's your first name? You all have first names, but they can have different values. Both of them have self, but they point to themselves. This self points to itself, not this one. You might look at this and be like, yeah, that's obvious. This is going to come up for a couple of head scratchers when you're programming. It's going to happen. What do you think is going to happen if I say, there. Take a look at this code. It's a quiz worth no marks. What do you expect to be printed out when I hit run? I'll give you 15 seconds to come up with the answer. I'll give you a big hint. Raise your hand if you were right. Good. It's because C student, I just said, become a pointer to the thing A student points to. It worked. This is how it works with objects. Those are pointers. There are ways to get to where the thing actually is in RAM. Great. So we created, I think I actually just spoiled all this activity for us because I just did it all. But we created a bunch of attributes. We could make more attributes if we want. What was the one the other day? Likes pie. LP starts as true by default because who doesn't? And then self dot. There, great. Now I can say, hey, what's your likes pie? Fantastic, true. It looks like Bob, or not Bob, likes pie. Fantastic. Okay. We have now, at this stage, okay, let me take a step back, actually. Whoop, wrong way. Is it actually recording? Okay, good. We are saying, here's a class. Everything in here is defining what it means to be an enthusiastic student. We wrote the constructor. This is the code that gets run and does the setup for the specific instance that we're creating, whenever we create one. We are creating one in this example, like on line 1 in the second cell. A student equals enthusiastic student. Wherever we see that name of the class with the brackets, that's when we're creating it. That calls the constructor, and that's when it gets created. So technically, in addition to all the code we have inside our constructor, which gets run, Python does a lot of other stuff behind the scenes. It goes to the computer, it finds a chunk of RAM, it sets that chunk of RAM aside to hold on to all the information it's going to have, and we create the pointer to it. That's all done as well. We don't have to write that code, thank God. But all that's done as well, in addition to the code inside the constructor, just like we saw where we say print out, I ran. It was silly to do that because it probably doesn't make sense for what we're doing, but it's just showing you that when we call the constructor, that code runs, just like any other function. Currently, this is a really boring object. Let's add some functionality. I like this one. Oh. I think someone even gave this as an example in class. Ask for a higher mark. Oops, that's not right. There. There. I have now written the function ask for a higher mark. Notice, if it's a method that we want to belong to the instances of these classes, we have to start with self. And in this example, I've decided that it's going to be, it takes self, it has to, and how high is going to be the mark we're going to ask for, the grade. Yes?
98.
98, perfect. We'll use that in our example. But see how like it actually, hello professor, my name is, and it actually will get the specific name of the student. Whichever instance we tell to run this function, run this method. I'm in your class, I would really like it, blah, 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 blah. Let's run it. Don't need this. Let's tell a student dot ask. Oh, did I not rerun this? There. What's going on? You're in here. And what did they want a 98. You know what? Let's dream big. 99. Let's see what happens. Oh, hello, professor. My name is Bob, and I'm in your 161 class. I would really like it if you just give me a 99%. Thanks, Bob Smith. But of course, if right below we have B student is going to ask for, they're a little more realistic. There. You know what, let's add another so it doesn't look so gross. When I tell B student to do it, it says, my name is John, and I'm in your 161 class. I'd really like it if you just give me a 98. Thanks, John Doe. The function is running for the specific instance that we told it to run for. Is this clear? Is it clear or not? Because objects, classes can really throw people off a little bit. It's nothing crazy, and the only way to get good at this stuff, like everything else in computer science, is practice, practice, practice. Like, is this so clear that I'm actually going annoyingly slow? No? All right, so I assume we're at a good pace then. So we wrote one function. Let's write another function, method. Remember, method's just the fancy word for the function that belongs to a specific instance of a class. So this, it's a method. And notice how here, if I wanted to get first name, I had to say self first name. If we go all the way to the end, I had to say self first name, self last name. Great. Ooh, here's a couple other ones. Show off. Whoop. Please do understand that these are silly, contrived examples. If you're trying to make sense of like, but why would you? I wouldn't. This is a silly example. I'm just showing you how it works. You'll notice in computer science, a lot of what this is me showing you, here's this idea, here's what you can do with it. Now go do other stuff with it. It follows all the same rules. Here's how you use it. Now go use it to do other stuff. That's what I'm showing you here. So now, I guess this one right here, it's a pretty silly one. Show off, they print out, I got 100 on my last assignment, everyone, I'm a wizard. And then it changes their first name to wizard. Why? Because. So let's see. I'm going to say, let's get rid of these. So let's do print a student dot first name. And then we do a student dot show off. Make sure I actually ran this. And then let's just print out their first name again to make sure it actually did what we wanted. Look at that. First it was Bob, then they showed off, and then it changed their first name to Wizard. Cool. Why? Because. And here's one. You know what, now's a great idea. Now's a great time to do. So I know I was saying follow along, but quick question. Raise your hand if you're actually following along, because otherwise I won't. Okay, perfect. Write your own method. I don't care what it does. Let's have a contest. Who can come up with the dumbest method? By the way, this special word here, pass, in Python, you need to have something indented inside your function in order for it to be like, yes, it exists. Pass is a way of saying like, here's something that means nothing. So it just makes Python shut up. Long story short, here's what I want you to do. I want you can give it whatever parameters you want, and I want you to write a stupid function that's called work way too hard on the assignment. It doesn't have to do anything related to an assignment, but write a function method to do something and test it out. And then after a couple minutes, we'll talk about what we did, just to see how dumb we could make this. You're going to want to delete pass, and then write your stuff. Oh, I guess it didn't return anything. We'll give you to 145 to come up with your silly function, or whatever it does. All right, who came up with something that's really dumb? No one did. All their stuff is not dumb. It's smart. What did you do?
I said I should have not taken this class because I got out and
Ah. I shouldn't take, so that would be like if they're not doing very well. Gotcha. What else? I'm just curious what other people wrote for their functions, methods. Oh no one else wants to share. Come on, let's get one more person, then we'll move on.
Maybe one that would take in like a percentage of your final grade. That like an assignment would say. I would say, holy shit, I have an assignment worth like doing more. I was worth this much.
There you go. Great example. You can do whatever you want. Remember, we are now defining what the attributes, what the values associated with instances of an enthusiastic student is, and we also define the methods, what those objects will do. We are inventing it. We can make it do whatever we want. It's up to us. So the next thing is going to be an example of another one of those important, fancy, special functions. Technically, you actually, if you don't write this, it gives you one for free. But I'll get to that in a moment. Repr. So, repr is a method that is designed to return a string representation, a string version of what this instance is. Now, what you want this to be, just like everything else, is entirely up to you. And it's going to be dependent on what the object is. In my example, here's what I wrote. Okay, actually, before I add it, okay, I'll add it. Don't need that. Okay, so I haven't rerun that code yet, so I technically haven't added that code to our class. If I go here and say print a student, it just gives me, oh, it's an enthusiastic student object at OX7FB1DFE0F978. Great, that's what it does. If I say print out this object, that's what it does. Remember that. So now I'm going to go here and I'm going to add this. Run. Now let's look at what this is going to do. It looks like it's going to say, okay, first name, space, what their first name is, new line, last name, space, last name, new line, student number, new line, current average. That's it. And it returns this string. And I'm going to say this right now. You're going to forget this. You're going to make this mistake, but this is another example of when you make that mistake, you go, right, I know. This repr does not print anything out. It returns a string. It returns a string. It returns a string version of what that student is. These reprs are handy for a bunch of different reasons, but it also is going to be really handy for like debugging a lot too. But let me show you what happens when I write this repr. So I'm going to run this code. So now I actually have I've added that repr for the class. Now let's see what happens when I run this. I'm going to create the object, and then I'm going to say print. Wait, this is killing me. I need to make these capitals. There. And I'm going to say print a student. There. If we write the repr, Python is smart enough that if you ever say, oh, print out this thing, it'll just call repr. In fact, technically, I believe what's actually happening is if you do stir of a student, so I'm not going to actually call print. If I say stir of a student, it gives me back this string. But when you call print, print will automatically take the thing, make it a string, and then print it out. So it just skipped a step. Long story short, whatever. If you ever want to get a string version, just like how you can convert an integer to a string, we can convert an enthusiastic student to a string. And because print automatically will convert the thing to a string, we can just say print a student. We can print B student. Look at that. First name Bob Smith, blah, blah, blah. John Doe, blah, blah, blah. Cool. So repr is one of those fancy ones that will just run automatically in certain cases. And there's a lot of those. If we don't write the repr, you automatically get a repr, whether you write it or not. You know how, like, with a function, if you don't write return, it adds one for you? If you don't write repr, Python's like adding a repr for you. But based on what we saw, what does the default repr do?
So like method wrapper at like whatever random address.
It says, yeah, main object at memory address. By default, it's just telling you like the memory address of where it is. Not that helpful. That's why what we do here, we call this overriding. We override what the repr's doing to be useful for our current situation. If we're writing another object, maybe a car object, the repr might be completely different. It might be way more intricate. I don't know. Cool. If we go here, remember I was saying, like, lists are objects. If I do that, I just print out the list. If I go into the list class and open up and look for repr, it's going to have the code that says add a square bracket, take the things one at a time, add a comma, to look what a list looks like. But the repr will actually be the thing that defines how to take that list and turn it into an actual string that gets printed out. See what happens if I do this. See? It's just a string. This is the string. It's not an actual list. It's a string representation of that list. Because this is what makes sense for the repr for a list. Lists have a lot of other information, like a size. Why did the repr not include the size? Well, because they thought maybe it wasn't necessary. So repr is an amazing, awesome one. Here's another one. EQ. Oh. Okay, I ran it. By default, I wish I didn't run it yet actually. By default, Python gives you an underscore EQ underscore for free, just like a repr for free. But the default underscore EQ underscore isn't going to be very helpful. Maybe it is, maybe it's not. Depends on what we're doing. So if it wasn't obvious, EQ is used to check if two objects are equivalent. If we classify them as equivalent, the default EQ will be true if they are literally the same one thing. If I say, in this example, if I said A student and C student in that previous thing, if they're equal, this would say true. Because it's two things pointing to the exact same one thing. Basically, it checks is the memory address the same. If it is, they're equivalent. That's the default one. But that's not going to be very helpful for us. Because I'm certain you can imagine I might make a student object with John Doe 00000, current average 0, and another John Doe 000, whatever, that are two separate objects that are supposed to represent the same thing. And if I check if they're equal, it'll say false. So right now, we get to define what it means for two student numbers, spoiler, what it means for two students to be equivalent. And here's what I'm saying. Another thing, that's going to be the pointer to one of the two objects. Self is the pointer to me. Here's a perfect example of self being pretty damn handy. Self is a pointer to me. I'm saying, okay, hey, me, what's my student number? Great. Then I've got another pointer to another object. It could technically be the exact same one, I suppose, but it's just another pointer. And through that pointer, we say, what's your student number? And I guess based on this, I am saying two students are equivalent if their student numbers are the same. I think in this example, that's a damn good idea. Because student numbers are supposed to be unique, right? I could check, are their first names the same? And if they are, we'll call them the same. But that's probably not a good idea, right? Because chances are there might be two Bobs in the class, but they're not the same Bob. If their student numbers are the same, they're the same person. We could write anything we want in here. We could write something stupid. We could say if 14 is greater than 2, that function will always return true. And no matter what you ask equivalency on, it'll always be true. That's dumb. But we are writing something that makes sense for what we're doing. If we wanted to check if two cars were the same, let's say we were writing car class, and we wanted to know if they were the same, I might do something like if their VIN is identical, then they're the same. We get to write whatever we want, though. So, I could call this, and I'm going to show it to you two ways. The first way, never do it this way. So I'm going to be really lazy and just say, okay, take that, take the default one, and make Bob Smith's student number the same. So we have A and B. They have the same student number, so they should be equivalent. So let's call A student dot underscore underscore EQ underscore underscore, and then I'm going to say B student. Oh, and I suppose we could print out true. And let's make a C student. There. So A and B are the same. Great. They're not. They have different student numbers. See how I wrote this, though? The thing dot underscore underscore EQ underscore underscore, and then I gave it the other one I'm comparing it to. So I'm saying, hey, A student, are you the same as B student? This would be very similar to me saying, it's effectively the same mathematically, if I were to say B student dot underscore underscore EQ underscore underscore A student. It's the same, okay? Doesn't matter. Because if they're equal one way, they're equal the other way based on how I wrote this. Right? So, the way I wrote this, never write it this way. Never write it this way. This is bad. Here's what you do. Let's clean this up a bit. There. Whenever you ask equivalency, Python's going, oh, equal, equal. That's the equivalency question, that Boolean operator. Are these things the same? Are they equivalent? It's going to go look up what the underscore underscore EQ underscore underscore is for the objects of that type. And then it runs that code. So A student equals equals B student is like saying A student dot EQ B student. And if I were to change the order to B student equals equals A student, same thing reversed. And if I change to the C student, it's false. So now we have a really great way of checking if two things are equivalent. It's always really good to write your repr and your EQ for any object you're writing. It's very, very good to do that. There are a whole bunch of other helpful, fancy methods like this with the underscore underscore. There's a bunch. But this is enough for now. So there, done. We've made, it's a really simple object. We've defined a very simple class, pardon me, that defines what an enthusiastic student object would be. It's got the constructor, it's got a couple of attributes, first name, last name, whatever. It's got a couple of methods. And I use those fancy other methods like EQ and repr as well. Great. That's it. That's it. You can write your own object now. That's it. That's all there is to it. We can add more complexity to it, but the complexity we're going to add isn't like new ideas. The complexity we're going to add is just more of what we've been doing for the last 2 months. And we'll see that Friday, I suppose. All right, see you later.